Hey everyone, again, my name is Lester Martin. We'll go ahead and get this webinar kicked off. I'm hopeful everyone can see my screen and can see myself. The webinar is titled, as you see there, Hive to Iceberg, Apache Hive to Iceberg, those two table formats. And it's really a topic around do we want to migrate or not to migrate, as it says. And I would go ahead and just set the stage and say, in general, yeah, we want to migrate. So we're going to take a little bit of time, of course, just making sure you agree why you might want to or should want to or will want to eventually migrate your Hive tables to Iceberg tables. But we'll call out some of the reasons why maybe today or tomorrow isn't exactly when you want to do this, because like anything, there is some effort involved that you want to make sure you're aware of and you're looking out for and taking care of. So let's jump on into it. Little connection before content. Again, Lester Martin, a little bit of information about me here. You can find that in the PDF if there's some additional interest, including how to catch up with me. A little quick agenda while we're there. Definitely take a look at that QR code there. Grab a picture of that on your phone and go to the web page and download our nice little cheat sheet, Trino and Iceberg cheat sheet. I think it's very useful. Again, if you don't have this when I change the button, go under the docs here in the webinar, and you should be able to pull down this presentation that I'm using. The QR code's in there, or just come to starburst.io, and we can help you find that cheat sheet really, really fast. So what are we going to do? Absolutely some slides and some talking. It's a webinar. It's a part of it. But I like to do a lot of stuff. No fluff or little fluff and some stuff, maybe is the way to say it. So definitely we'll run through the evolution of the lakehouse, and it's really about kind of talking not just what we want to do with something like Apache Iceberg, but setting the stage, and then we'll run through the table formats, run through a SQL engine like Trino Starburst, and then ultimately we'll get into where we want to be the meat of the conversation about if we should or shouldn't migrate to Hive, and then what are some of the gotchas, what are some of the patterns, what are some of the ideas along the way. All right, let's see if I can do it in 3 minutes. An awesome colleague of mine can do it in 3. I'd probably take 4 or 5. I'm kind of elaborate at times, it seems to be, or not succinct. So absolutely, she introduced a beautiful Charmander evolution here. And if we think about the data warehouse that we had for a long time, we think about the data lake kind of being that next evolution that we've been in that space for some period of time, as an industry, at least over 10 years in many ways. And then maybe trying to find a way to say, hey, can we merge all those together and really see a Charizard? So let's see if we can see those little icons as we move along, if we think about in that context. No need to spend too much time and talk about the enterprise data warehouse. I think everyone knows all about this, and either you're a direct user, a builder, or you're aware of it. This is a set of technologies that have been out there for some time, built on the classical relational database systems, oriented heavily to OLAP. And everybody at any size and scale company has at least 2 or 3 of these data warehouse vendors. Gave us a lot of, we've been here. I guess the gotchas are price, vendor lock-in. To be honest, probably still scale. That was an issue why we created the data lake and all that good stuff as well there, and absolutely very structured in nature only, just what we're built around. That some of those problems around size and scale, around structure requirements, around validity requirements, and introduce the concepts of schema on read and things really got us to the data lake. And you think of the data lake maybe in its earliest version, Apache Hadoop. Spent a lot of years in that space myself as well. Likely your company has a Hadoop cluster or 3. Spattered around. The gotchas might have been that by itself, the wins, of course, are scale and performance, scale and price, I guess is really the best answers. We were trying to solve problems that we just couldn't solve, or they were just way too expensive. So the bads of that, of course, is just, okay, they brought you a limited set of skills, and then we had to do a lot of one-offs to kind of make, start to fill that in and backfill, and makes it a little bit more enterprise ready. What do we want to get to? And this is a term that's out there. It means a lot of different things to different people. The data lakehouse, to me, it means kind of what we said a minute ago, taking those benefits of the enterprise data warehouse, those benefits of the data lake and try to mudge them together and create something a little bit better. And some of the tenets here, at least today, nowadays, we think of actually going back and separating storage and compute again, unlike what we did at Hadoop and brought it together, mainly for network problems, network speed problems, but break them back apart, have those economies of scale individually. Absolutely, have that performance and scale we've been building up to the data lake, continue to grow that. We'll talk about Trino, we'll talk about Iceberg today. And 100% bring transactional support around classic things that you can do in relational systems, EDWS systems. And I'm talking about data manipulation, data modification, language updates, not just inserts, but updates, deletes, and even our good friend, the merge. And again, have transactional controls around, follow that acid test of atomic, consistent, isolated, durable. And then, of course, keep that benefit of structured, semi-structured, unstructured. Now, it all depends on what you're doing. When we think heavily about the SQL access, obviously the structured side makes more sense. But as we slide back into that data science space, that machine learning space, definitely in some of the newer initiatives in AI, sometimes less structured data is going to make a lot more sense. All right, there's my 3-minute version, probably more than 3 minutes. But let's just talk about, if you buy all that and you're on board with that, what's some of the best components out there? Well, I think this intro slide says, let's use Trino. And I guess to talk about Trino, you got to remind where Trino came from. Trino came from a framework called Presto. Presto came from the good folks at Facebook, who also brought us Hive. And really the reason why we had all that good stuff was this reason, right, you see here. Hive brought us SQL to the data lake, but it focused on, again, those problems that just couldn't get solved. So often, because of that, things took a long time, and we built lots of resiliency in this system. So if it took hours to do something, let's make sure it didn't fail. So the same team said, hey, you know what? There are still questions that we ask at data sets of size and scale that we believe could be interactive, could be something that a human or process is waiting for a response to make yet another request in there. So ergo, the same or larger organization, Facebook, create a faster engine and use both for some period of time. Absolutely. Some more things that we did in Presto, such Trino, were absolutely, breaking apart, kind of keeping it not Hadoop, separate the storage and the compute. No, don't co-locate them together. And don't be a dialect of SQL, be ANSI SQL itself. So that underlying engine, Trino, as we call it today, it's an open source project, follows the standard a centralized manager and multiple worker kind of node strategies or stereotype strategies, meaning that coordinator or manager is really the point of contact that people in process talk to. They think of Trino really as a database in many ways, it seems like to them. Submit a query, get an answer back. What happens behind the scenes is we are being a single point of failure, a single point of access to a variety of data sources, not just the data lake, even though that's really what it was intended for and built for. We want to pull in data sets, data systems from all over the place and let them be merged together. But ultimately, that manager, the coordinator, is going to get a query, figure out what's the best way to attack it. What we often in the database world kind of call a query plan, build a query plan, and then run that query plan in the scale out space, the workers. Those are the spaces that are going to do the heavy lifting of data, implied by those arrows, a little thicker than the other ones. The top ones are really talking about metadata from the coordinator. And what else do we want to do? Well, we absolutely need to think about a table format. Now, if you're not familiar with the phrase table format, but you are familiar with Apache Hive, then Hive is a table format. Table formats are the way or the mechanism that we declare where we store the data and the metadata about a data lake table. In Hive, as you see in this kind of picture here, we store some of that information in a thing called, it's labeled HMS here for the Hive Metastore. We often just call it a metastore. More recently, people call this more of a catalog. So some kind of catalog that keeps a lot of high-level metadata, structure, definitions, that kind of stuff, maybe some high-level statistics. But that metadata also tells us where to go look at. The pink stuff here, hey, where is the data physically located? Where's a folder I can go find? And what am I going to find when I get there? What kind of file formats? JSONs, Parquets. that kind of stuff. So Hive is a table format. It's the original table format, not really a specification like the other ones have done, but some folks have created additional table formats, and they were really trying to solve a variety of problems. You see some of these on the left here. Now we talk about rigidity of partitions. Again, we're making some assumption. Folks have a background in Hive here. So partitions, as you might know, do need to be declared to consumers, to users. They need to be able to put that in a where clause in a very specific column name and not forget it or not get the benefits. So we want to, kind of lighten that up. We want to allow schemas, including the partitions themselves, to change. And that's something that's a lot harder to do in Hive itself. You see some other things that object stores optimization is really about the way Hive and knows subfolders and the way object stores work. We end up being a little bit painful. We have to do a lot of digging through that kind of the object store such as S3 that would work better maybe with some other alternatives. A couple other things: performance, scalability, of course. Kind of after the fact, transaction was brought to Hive, and it's where it works okay, but it doesn't provide some additional benefits we can, and it doesn't always work the same, or not even often in some cases, different place. So we like to say it's an inconsistent kind of approach to ACID transactioning. We'll talk about at the bottom one. There's no real inherent table versioning either that's built into Hive itself. So these are some of the problems that we have out there. And some of those problems are the reasons why Iceberg and a couple other table formats were created. And this one was created at size and scale, or at a company that we all recognize, Netflix. These folks did this for their own benefit. They were using Hive and they wanted something more. They built this, they ran it all in Trino. It worked really, really well. And really, as you see there, it's not necessarily trying to get rid of everything we've already thought about. It really tackled that question and says, if a table format is about the metadata and the data and how they are all captured and stored, the real answer, and I'll show you in the next slide or next slides, is that it moved the data, the metadata, down into the data lake. Put it as files on the data lake, just like the Hive files themselves are for the data. And absolutely, we leverage orcs and parquets and avros, other file formats that already existed. So we didn't want to change how that works. We wanted to tackle the metadata, and we wanted to make darn sure that, like the goal has always been, to say, you know what, not only Trino and Starburst can access these Iceberg tables, but can a variety of other processing frameworks use them? Absolutely. Can they also store them on a variety of data lakes? Absolutely. So we want to make sure Iceberg is definitely at the middle of that open data lakehouse space. All right. So as we said all along, why don't we take the data lake options and the freedoms and the flexibilities? Why don't we take those well-known, well-behaved warehousing concepts and mash them all together? So there you go. We want to make sure people just see a table. Partitioning is there because we needed it to be there. It's not something we need to make folks deal with themselves. We accept that changes will be made not just in queries, but in the way data is stored and the way it's accessed. So we want to be able to change a lot of that stuff behind the scenes and not let folks be aware of it. And we want those transactional things, but we want to go ahead and get some features. What if I make changes? Can I see the data an hour ago, a week ago, or more or less? And could I maybe even not just look at it? That's called time travel. Could I roll back? And that has a lot of benefits in non-production environments, and it absolutely has a few important benefits in a production environment should you use that as a back-out strategy on a large effort or something like that. All right, let's do a quick demo, because as I promised, we can do slides all day, but maybe looking at something would be useful. So what does my demo say? Now, at the very last slide, if you want to look at it, there's a link to a GitHub project right here, or a folder within a project. In this folder, there's just a couple files here. These SQL files, demo setup, demo steps, are what I'll be running should you want to try this kind of stuff. There's a recording already of what we're doing in case before we publish the bigger recording, you need to look at some stuff and move on. All right, so here's what we'll do. We'll say, hey, let's build a simple little table. All right, I'm a big fan of the book Dune. I haven't seen the second movie yet, but I know the story too well. So let's create a table called Dune characters. I'm going to create it as an Iceberg table using the well-known Parquet file format. And what am I going to do next? I'm just going to add 3 records, some characters from that story, and I'll do a select on that. Again, this just looks like a database. We all know this stuff. There it is. Vito, Jessica, and Paul. And then I want to make the point that there actually are some additional details about. There's some metadata that I can start asking Iceberg about and say, hey, tell me from a thing they call metadata tables, right here, this dollar history. Tell me from dollar history what's going on. Now, this is a real simple one. It just mentions a few important things. And the most important one is this snapshot ID. These are our versions. These are the identifiers that say that happened, time-stamped and everything. And a lineage thing. This one's parent was that one. These two are the first snapshot or the first version was creating the table. Anytime we make structural changes and or anytime we make data changes, we get a new version. And we probably won't be able to talk about today how, but I'm going to tell you now, the good news is it doesn't cause a performance issue by having all these versions, because that's usually where people's heads run to. All right, so let's do some more manipulation. Let's do some more adds, simple stuff here. Add another 5 records and select and make sure not only do 5 records go in, 1, 2, 3, 4, right there, 5, and then we have 8 records, 5 plus 3, pretty normal stuff. And again, pretty normal stuff that I probably would have yet another version. Yep, version 1, version 2, version 3, snapshot 1, 2, 3. So what I'm going to do is just real briefly, and then we'll get done with this. I'm going to briefly say, look, why don't I go steal this middle one? Why don't I go steal this snapshot ID, and I'm going to put it here. So I'm going to run a query that says, hey, select everything from Doom characters as it was on this particular version. And that particular version was the middle one. If you remember, the middle is created table number 1. Add 3 records was number 2, and adding 5 more records was number 3. So I'm going to see there's just those 3 records. Now, using those numbers might sound a little painful. The good news is you can do things time travel for a timestamp. So you can simply say current time minus a minute ago, an hour ago, a day ago. But users also have the ability to look at these details. And there's more in those metadata that tells you what has changed and that kind of stuff. But I just wanted to give you a quick introduction to that. And just to further put it to bed, could you roll back to that point? Could I, unknown snap. Oh, yeah, I got to use the actual snapshot ID that I'm talking about. To snapshot. Oops, let me open it up. It said unknown snapshot ID. There you go, because that didn't exist. So I'm going to say, hey, do a rollback to the snapshot, and then I run on line 63, another select. Okay, there we are. We're formally back there now. And you can you can go a whole bunch of ways. You can fork, you can roll back, you can do a lot of variety of things with this versioning stuff. All right, so let me look back at my slides. All right, so that was just to kind of give you a flair. Again, it looks and smells like a data warehouse, but you have all that other stuff, other cool features. Well, that's some of the cool features, the versioning features of time travel and rollback. Now, I am absolutely not going to cover this slide, but I wanted to put it in there to just kind of bring home the point. What I was trying to say is, if you look at these dotted lines, you look on the left, you look at the upper right-hand corner, it's kind of saying the truth is, or the bottom right, metadata and data live together in the data lake. These, all we did in Iceberg is just really created another subfolder inside of basically our Hive tables location. We said, hey, let's create a slash data folder. And in there, put the files you would normally put for a Hive table. And on the peer at the top level, let's create a metadata folder. And there's a hierarchy of metadata files that support all kinds of neat stuff. And the good news is you can learn all about that, but you do have to have access to kind of go at the data lake and see them, or you can investigate those dollar history, dollar files, dollar partition folder, metadata tables, and then use SQL to interrogate and get real answers that really make a little bit of sense. I want to make that kind of point that this data moved out there. And I mentioned that a meta store is often thought of as a catalog. We still need a catalog to make it all work, but the catalog really now, instead of containing lots and lots of information, it basically says, hey, what's the particular file that is the current that represents the current version. All right, again, I promise not to go into there. I just want to introduce, there is complexity in there. and it's all stored on the data lake, not necessarily deeply into the catalog or the meta store. And just to remind ourselves, the whole point here is to make it better and easier and less Hive-like or less non-normal-like. So we want things to just work. There's a number of bullets here. We can try to tackle them this afternoon if we have time as well. Code words like "don't steal attention." The mission here is we don't really want consumers to be aware of the fact that there are things that these systems, care and feeding activities that need to occur. And the good news, even for the operators, the data engineers, we can automate all that good stuff as well. And absolutely, we want some concurrency to those changes. So at least an approach for the engine to deal with concurrency in case there's a problem, or to tackle that things can go in. Usually we're going to say for the consumers, we have read committed data as our isolation level if you're familiar with those things. All right, keep on pushing on because I want to get to the migration stuff. Just a good slide to reinforce one more time what we said all along. Hey, take the best of data warehouse, the best of data lake, put them all together. And as our dev advocate, Monica likes to call it the doodle of the data architecture. I think it's pretty awesome, and to be honest, you can create your own special doodle too if you're really not careful, and maybe that's a good thing as well. All right, so to put it all together, at least what we're hoping to be a target infrastructures, continue to leverage your data lake, continue to leverage these open file formats, these good file formats, wrap around that using a table format, moving from Hive to Iceberg. Why? So we can get that lake house, the data lake plus the data warehousing features that we've been talking about. Absolutely, you need a best in breed, first class query engine. We got one, Trino. Definitely Starburst will help you run Trino and all those things. And we go ahead and accept that. That's great. We're talking about migrating Hive to Iceberg today, but there are still things that aren't in Hive yet, and we still need to access those things. Absolutely. Trino is aware of and integratable and openness and optionality oriented to allow all that to come together, not just as a single point to go look at it, but a single point to federate or join data sets across all that. Good stuff. Oh yeah, and wrap it with all of our good stuff, security governance, lineage, all these awesome tools that really make it shine and come together as a platform. All right. Take a deep breath. That was the backdrop to get us here. Let's talk about migrating to Hive and maybe why you might not migrate to Hive. Again, the assumption is, at least from me, if you're here that you want to or you're considering, it's not like you're, hey, I would never do this. But, like everything, this is effort, and we do need to make sure the old juice is worth the squeeze. So let's talk about what are some of the things that might be difficult. There's a hard stop on this one. This is this notion of, it's not going to say that if you have external tables, so if you're familiar with Hive external versus Hive managed tables, it doesn't mean we cannot move away from external. We can actually do in place, we'll see these migrations from external tables. But if you use those external tables with an overarching data pipeline of other systems are dropping files magically in magical folders, and that's your entire ingestion process, then for that table, we probably can't migrate. We can't migrate that. We need to make, Iceberg requires that all tables are managed, meaning we need to use the front door, insert into. So I will say, as I was explaining this to an internal person here, if your data pipeline is built around an external table that people drop JSONs to, and then you very frequently sweep that and insert that into a larger table, don't change that. Leave that alone. Leave that at an external table because that's just how it's tied in. But look at that next table that you're loading to, the data that has all the records from all the time and those kinds of things. But it is a hard stop if you do have externally ingested files, not just if you have an external table. We can migrate past that. What else are gotchas that we'd have to tackle? Well, the naysayers start to come out and say, well, all that stuff sounds cool, but you're telling me there's level of effort here. There's something work to do. I don't need all that stuff. Okay, I don't really need that. I would only encourage you to start to evaluate that maybe you could have. What would your world be like today if you had these nice benefits? And I'm leaving performance out for a moment in time. I'm just talking about features. So I encourage you to consider that. But again, if you're looking for reasons not to, I guess that could be one of them, but I don't necessarily love it. This is the one that's a little harder to sell to ourselves. If we got past I don't even want the features for some reason, but you know what I have works today, and it's going to work for a long time to come. And the only way you're really going to know if it's going to work for a long time to come is you've done some size and scaling, you've done some anticipation, and you're varied. The reason people at Netflix created Iceberg wasn't because they went, wow, this thing's, they didn't make up that it's not going to scale. They found out for them it's not going to scale. And I broke it in kind of two pieces. I said, hey, are there metastore performance issues? If you think about all those tables having all that metadata in the metastore, the catalog, there are lots of calls that constantly go to that service and that underlying database, times every table, times every query. And at size and scale, that metastore eventually is going to get kind of hurried, get a little overwhelmed. So this is one reason I called it very specifically out. You might not have hit that yet, but you may. And it may not be just because of that one table, that one set of queries. It may be your entire data lake thing to think about. But again, if you don't have a problem today and you won't have one tomorrow, it is kind of hard to say do effort because of that alone. So that's really all this says. If it all is perfect, if you love what you have, Lester, maybe not anyone else, but Lester says, wow, that it's kind of hard just to tell you to do something if you're just not going to get a value out of it. So I expect you'll get value out of it. Hey, lastly, another huge reason that we're always going to have trouble, especially in corporate cost centers like IT teams, as opposed to maybe a product team, is sometimes there's just not a lot of resources available. So what am I saying? I'm not saying give up. I'm saying look at this, evaluate this now so you can start planning in your larger planning cycles to put stuff in your budget to actually take care and tackle this. And while you're doing that, reach out to our account teams. Reach out, so there'll be a link at the end of how to kind of request some help if you don't have a point of contact, and you always have Lester as a person you can find. So you put all that together and say, why might I not want to migrate? There you go. That's just the same thing. And I put all those little decision boxes and stuff and started to build a little flow chart. And I kind of ended it with a phrase that says, if it ain't broke, this little box, if it ain't broke, don't fix it. And I know internally, I got a few folks that, is that the message we want to say? As your trusted advisor, as a system that can absolutely work with Hive, I believe that is a message that's for some folks is the right answer. But I'm going to go ahead and really turn it around and say, but I know in my heart of hearts, I've been doing this for over a decade, just this stuff, Hive, Iceberg, etc. I know in my heart of hearts, this is the right thing to do. And I'm going to go ahead and tell us what we all know. If we don't start moving forward, we're always just going to be stagnated. So, if it ain't broke, don't fix it, but don't get the tattoo. Use that as a colloquialism and don't write it on your skin, and decide, as that guy says sitting on the box here, decide when we can do this review again. And in reality, this little decision tree could be thought of as your whole system, or more fairly, table by table, especially once you start to dive in. We'd love you to do a wholesale migration, but there may be reasons some things just don't make it. Okay, so we are there. We just said, let's do it. I want to do some migrations. What's the strategies? What's the general approaches? And I think everyone's going to tell you they're really just two big approaches. We're really getting tactical here. We're starting to think, okay, table by table, how am I going to tackle this? And there really are these two important ones. One on the left is the one we all know and love. If you're in Hive and you changed your partition strategy, and you can't change partition strategies in Hive, what do? You build a second table, define it the way you like it, and you start bringing the data over into it. And at some point in time, you say, that's the table, and you stop letting folks access the old table. And you own that process. Lots of benefits of that, lots of checks and balances, let you control the scale, the speed, the schedule. It could be all turn it off and do it. It could just be behind the scenes where don't even notice it. So that's a classic kind of approach. But we also have this notion called an in-place upgrade, an in-place migration. And think of it as a hijacking. If you think about the data is already on the data lake and the metadata is already up there in that catalog, couldn't we just read the metadata, read the data, because the metadata stores more than's in the meta store. It stores a lot of that columnar file level details. Couldn't I read all that and just lay down the metadata on the data lake and then just change the catalog and say, hey, it's not a Hive table anymore, it's an Iceberg table? Pause, wait for effect. Yeah, absolutely. And the only problem with that is there's some criteria. To get magic, you do have to fit the little set of gates. So I'm going to walk you through those gates and play with them as I go. All right, so in place migration requirements is to recycle the files. Don't rewrite anything. Don't rewrite the data files. Build metadata files, change the catalog, and be done. So you can think about that. That's going to happen very fast. To get that, what do we need to make sure we have? Well, check roadblock number one is do we have the underlying files and formats that Iceberg can support? So Iceberg and the modern table formats, the other ones out there, are more restrictive than Hive is. Hive lets you have a lot of different technologies. That was file formats. That was always a design tenet. But there's a lot of reasons. It's really about performance. We want to say, hey, if you got Parquet orcs or avos already, good. You're a good candidate. I'm going to argue that your tables of size and scale probably have already tackled this. And if not, you probably need to do that anyway. And I'm going to go ahead and step it up. Even if you don't have a performance problem, you think today, or you identify you have a performance problem, if you're going to do any change of file formats, do the table format as well. All right. So in-place upgrades, if you have those, you're off and running. But if you don't, it's going to fail. And let's just do one. Let's see one fail. All right. I went ahead and earlier I have a little table called the customer Hive JSON table. And the name should tell you what it is. It has customer data. It's a Hive table format. It's implemented with a JSON file. So I did a quick number, only 1.5 million rows. And then I said, let's look at the table definition. There it is at the bottom. It is type is Hive, format is JSON, 1.5 million records, nothing special. All right, so I said I have that cool table that I want to do a conversion, and it's going to fail because I told you it doesn't support JSON. So I'm going to try it anyway. Alter the table, and this is how we do it in Galaxy. We just kind of say, hey, change the properties, change the type to Iceberg, and he simply just said failed to migrate table. Good news is, I can look a little deeper, go down here to general, kind of scroll down here and notice that it said, hey, I got an unsupported storage format. You gave me JSON, and I don't know what to do with that, so I am not going to mess it up. The good news is that didn't make anything break. Your table's still fine. You just have to take a different approach. You have to do a shadow migration. What's a shadow migration? Well, it could be as low-tech as what you see there. Hey, create me a table, and I called it the Iceberg from customer Hive JSON. I set it up to say, hey, it's an Iceberg table, and then I just did a select into. So I did a C task, create table as select, and then I did a quick select star from. Well, oh no. And then I said, and you would do this a little bit more strategically, testing all that stuff. But I'm just going to say, at the end of the day, what are you going to do? You're probably going to drop the original table. You're probably going to rename the new table to the old name, and then I'll just run the rest of them. And then what are you going to do? You're going to say, hey, run those same two queries over. Select cust Hive JSON, which still says, 1.5 million rows. And then if you look at the definition now, it looks a little different at the bottom. It's an Iceberg table using Parquet. So we built a brand new table. We wrote the files through the old table ways, swapped it around. So not anything but good old-fashioned brute force, but that was our problem. We didn't have applicable file formats. I think this is one that's probably going to get us most. This is the one that's going to probably bite us and say, hey, I can't do that in-place migration because there's some data type incompatibilities. Things like chars, they don't support. We only do var chars in Iceberg. We don't have anything. We don't have the tiny ints. We have big ints. And then the one that's really painful is, the one that's really painful is that Hive is going to do what we call a timestamp 3, and Iceberg's going to use a timestamp 6. And it's very likely you have a lot of Hive tables, especially those really big ones we do analytics on, that have timestamps. So this one's just not going to convert. Now I'm going to show you how easy that is. Once you identify it, it won't convert. What you do about it. Pretty easy stuff. So let's do the same kind of thing we did before. I got a web page data set, Hive, Parquet. There it is. Create table, Parquet, Hive. And if you look really close, I've got some chars, char 50, char 16. I got a couple different chars that I know are going to fail. So let's just make it fail. Attempt our in place upgrade. Failed to migrate table. Didn't tell me much more. So I'll take a look over here, and he's going to scream at me right there. Hey, I don't know what a char 16 is. Iceberg, we don't do char. Okay, well, what do I do? Easy breezy. You just simply do the same thing we did before, but oh, there we go. So I said, cool, let's try the in place failed. So let's try that simple thing I did earlier. Try to just do a CTAS, save in there. It's going to have the same problem we just said. That data type is no good. Char 16 is nothing that Iceberg can support. So when you have those problems, all we're really saying is you got to do things like you see here on lines 115, 117, and 119, these casts. You need to, unfortunately, upcast those elements. And the good news is we really are talking about upcasting too. We're not saying the things that are problems, there are answers for them. They just need to be more coarse grained. And yeah, we have to tackle it in the day. So there we go. I created a new table. I called it Iceberg from the web page, Hive, Parquet. Did the same thing, except I ran, specifically called the columns out, did a casting, and there's nothing wrong with that at all. That's a good thing. Small data sets, why that one happened immediately. And then ultimately, what can we do? The same things, drop in an alter, and I'll just do a describe at the end there, because I really want to focus on not that it became an Iceberg table, but that that Iceberg table now has varchars and those instead of chars in there. Now, again, this one was no problem with the other ones because my dates were dates. They weren't timestamps, but it would have been the same issue. So when you do have these incompatible data types, again, can't do an in-place migration, but all we're really talking about is casting them, read them, cast them. So it's still a CTAS, or it doesn't have to be a CTAS. You can create the table and do inserts, and there's probably better reasons to even do it that way. For my demo, I just want to keep it kind of quick with the CTAS. All right, so file format types and data types have to be in good shape to do a simple takeover. All right, we did the demo there. Now this one's a little interesting. And, when you're talking about object storage, the last thing you want to do is say the word buckets or bucketing, because you're going to get confusion. I'm talking about Hive bucketing, table format bucketing, sometimes called clustering in classical Hive, but it's always been called bucketing. We call it bucketing in the Trino world. And all I want to say is if you have bucketing, if you don't know what bucketing is, tune me out the next 90 to 120 or 180 seconds here. But if you have bucketing or clustering, likely you probably even have partitioning, because it is a strategy we use for gigantic files. But if you have bucketing, the bad news is, or the good news is, you can do an in-place upgrade. And the weird news is the in-place upgrade is going to ignore in the new table definition your bucketing definition. So the files that were already pre-bucketed are going to be that way, but arguably the table is no longer bucketed. So I'm going to show you what that looks like and show you how you might tackle doing that. Okay, I did a bad thing. I looked at the chat, which I'm got a lot of folks here. I didn't introduce them all. Hopefully they introduce themselves in the chat at the beginning. If not, hopefully as they help you out, they'll mention themselves. Thank you, team. So bucketing is ignored. So let me show you a few things here. I will go ahead and run a bunch of stuff at once. I'll say, hey, do a select all on a table, orders, Hive, or bucketed. Great. Select all. Looks like this: orders, prices, dates, nothing too special. And then I said, do a describe of that table. So show me the field names and field types. Nothing too special here, but you might notice at the bottom here, it says something is a partition key. In fact, this is something that Iceberg will take care of for us. Customers never need, or users never need to know what the partition key is. They just need to run a query, and we'll leverage that stuff. But the main thing I want to point out is, there's nothing here that tells me a lot about the clustering or the bucketing. But Okay, I showed you a few more things. I showed you since it was bucketed, partitioned, it was partitioned on this field. So we should expect about 5 partitioning folders. And then here's the show create. This is what I really want to focus on. If you look at the bottom here, we got our partitioning. We didn't introduce that before. Again, large assumptions that you know a bit about a more advanced Hive. So partitioning. So got a folders for order priority, but then I did a bucketed by the customer key. And when you bucket, you have to supply a bucketing count. How many things, how many files will get created? 5. And in fact, once you do bucket, you can do one more thing with the bucket, the data in the buckets. You could sort them. I chose not to sort them, so it just says not sorted, but it has to call something out. All right, so I have this bucketing system. So let's do ourselves a favor. And instead of going straight to the data lake, let me just run a query. Hey, tell me, because Hive and all this stuff, they have a way to say, show me record by record where you're sourced from. So from that, I just said, hey, show me a distinct list of files that are back in this entire table. Now, this may or may not make tons of sense, unless if you don't know this bucketing, it won't make any sense. But those that do know, if you look really closely, oops, I could do it that way, but I was trying to just look at this. If you look where my mouse is wiggling, there's a folder, order priority equals 1 urgent. And if it keeps scrolling down, 2 high, 3 medium, 4. So those are the folders for my partitions. And then what do you see next to that? You actually see the end of the file name. So there's the folder, order priority is 1 urgent. And then this thing is a file name. What's so special about it? It's a bucketed file, meaning that this value right there is the bucket number. So if we look really, really closely, what that means is in that each one of these folders, we're going to have 5 files: bucket 0, bucket 1, bucket 2, bucket 3, and bucket 4. Does it all over 0, 1, 2, 3, 4, 0, because it's a zero-based naming convention. So bucketing, that's a Hive table with bucketing working like it's intended. Let's alter it. Again, it's a longer conversation if you're not familiar with bucketing. I promised 120 seconds. I'm way past that, so I'm going to push on. So I did an in-place upgrade, and it actually worked. I can say, show the create table, and it's going to tell me, absolutely, you're now an Iceberg table. It's using orc. Why? Because I set it up with orc. Partitioning carried forward just fine, but there's no mention of a bucket here. Okay, no mention. There's no DDL that says bucketing. So, well, what's up with the files? Aren't they still bucketed? Well, if you run that exact same query, you're going to find exactly what you saw, because we did an in-place upgrade. We didn't rewrite any files. So it kind of looks like it's still supporting bucketing. Bucketing is a file concept, building specific files. So those files already exist. But to really bring it home, what if I turned around and said, hey, let's add another partition of data. So I added an insert into this table, order priority. So I've made up a priority called bogus. I want to create a whole new partition folder with just these 1.5 million records that you see get added here. And if we do that right, let's just go look and see what we see as backing files. Now here's where it gets kind of not silly. Here's where the rubber's going to hit the road. Remind us, there's the 1s and the 2s of the previous partitioning, and they had files that look like bucket 0, 1, 2, and 3, and 4. But here's what just happened just now. There's now a folder called order priorities bogus. And there's a little bit more than 5 things here. In fact, if you look at them, they are .org files. They're physical files. There's about 7, 8, 9 of those or whatever. And it didn't honor that concept we had. If bucketing was honored, we would have created 5 files, not a whole bunch. We created more because the system was could split the work up more, and it just didn't know anything about the bucketing. So the main thing is, if you really, really need bucketing and you really want to continue to have bucketing, you're going to have to do some kind of a shadow migration. And you're going to have to learn that bucketing is just different in Iceberg. Similar features, similar benefits, all that good stuff, but it's actually implemented. I'll go ahead and run this, and then we can look at it on lines 170 and so forth. I'm going to say, look, build me another, go ahead and drop. I went ahead and dropped the bucketed table that I did an in-place upgrade and just rebuilt it. So that's what all of that does for me. Oh, and I just did it all. There we go. I did a select all. I did a CTAS from the real source is this other system called TPCH. What I really wanted to point out is this. The way, okay, let me take another deep breath. What I recreated was the original Hive table. There it is, bucketed by, bucketed count. Okay, we're back to where we were a few moments ago. That's all I did. Sorry. Now, here's what I thought I just did. Let's do a shadow migration. So I'm putting my silly ice from prefix in front of the table name. Formats, Iceberg, types Iceberg, formats orc. Okay, could have made it Parquet or Avro or whatever. But look how Iceberg is tackling bucketing. It's actually tackling it as partitioning. And it actually has a cool helper function called bucket. So what we're saying, and if you use bucket, so let me go and show you what was created, but basically it's going to create folders instead of files that has those things that are bucketed properly based on the customer key. So again, we're way deep into this bucket conversation. I need to look at the time one more time and finish this up here. Bucketing is just different. It's implemented differently. We still have the same number of records. You can look at the create table. You'll see exactly what you see there above, create table. The bucketing shows up as just one of the tiers in partitioning. If you only want bucketing with no other partition, just slide that bucket cus key over. And then really, here's where it just looks different. But if you think about it, it's really going to act very similar to what we do in Hive, meaning here's the folder way over here. I'm just going to click on one of these so we can see it. The folder there's the slash data that Iceberg does. There's the order priority is 1 is urgent. That's a folder. And then guess what? The bucket is another partitioning folder. So cus key bucket equals 0. There's another folder called equals 1, 2, 3, and 4. And then within those, we're going to get physical files. And I'm going to stop there because I'm trying to not talk about what bucketing really is and all that. Those that want to hang around at the end, I'll try to stay on the call or something. We can try to talk about it if it's appropriate, if you need to, or you have my contact information in the PDF and that kind of stuff. And I'll be glad to go into more detail. Main thing was to say we don't have bucketing done the same way. Bucketing is, in fact, a type of partitioning, but the benefit is the same. If someone's looking for a particular cus key, it's going to look in a particular folder now instead of a particular file. Same, especially when bucketing did create multiple files. All right. So I did that when I want to get past it because I spent all day on it. So let's just go ahead and drop it and swap it just to finish my little test out there. And no need to look at it. It works just fine. Let me slide back over here. So bucketing, watch out for it. So all that said is, it's rigid. It has requirements. Again, I think bucketing is a less used feature for a lot of folks. So it's usually used on a very few large tables. So look at that hard. But if I look at the other two, the first one, your large table sets, tables, you likely already have a good column or file format like Parquet and Orc. And the one that's really going to bite you is that middle tier in my book. That one's going to hurt you and cause you to go down that shadow migration. But, it does work. And I might as well demo that the in-place can really work. So here we go. I've got one called, let's look at the table. I'll run all these at once and we can look at them piece by piece. So let's see if we got a mildly complicated table. We got a show create here that says, hey, I'm a Hive table. I've got partition, 2 tiers of partitioning, market segment, nation key. I even added a bloom filter. I'm not going to discuss what a bloom filter is, but I did. I'm using Orc. And then ultimately I said, okay, if I did all that, if that's what it looks like, could I run an alter table right there on line 209 and 210? Can I turn it into an iceberg? And if it's so, can I look at the show create table again? So I did. And the show create table now says, hey, I'm an iceberg, as it's seen on the bottom. And the rest is the same. The syntax is a little different, but it's still partitioned with 2 values. It's still got the bloom filters. It works pretty darn good. And like I said earlier, it actually will work just fine with an external table as well. I didn't make that one external, but that definitely would work if you have that scenario. Okay, in place does work. All right, we're doing great on time. We got about 10 minutes left. I would just say two important things. One, take all that stuff and kind of put it together. These are just all those decisions and demos we've been seeing, and kind of have this Hive to Iceberg migration tree. You have this in the PDF you're downloading. You're definitely welcome to reach out to myself or anyone at Starburst to talk about this, or Slack channels, or wherever you want to. We want to get into it for sure. But in addition to that, I think there are a couple more things to think about. And, for no matter what, we're talking about a migration. And even if you were lucky enough that you could do all the push button, we don't just remind ourselves, this has nothing to do with this Hive to Iceberg migration. It has to do with the word migration. Test, do a little more testing. Make sure you know what you're doing. You follow all your patterns of how do you get out of trouble faster than you got into it. All those things are important. I will say the second bullet says, hey, let's automate some maintenance activities. What am I talking about? I'm definitely talking about things like compaction that we needed to solve already in Hive to keep squishing together, small files and that kind of stuff. The good news here, they get a lot more automated. There are a lot more one command. Iceberg and Trino can just do those things for you. And we can definitely automate those from your job scheduler, from our little job scheduler, lots of different places you can automate that kind of stuff, or just bake it into your data pipelines. And then, again, we're not going to oversimplify, do a create table as. We're likely going to say, I got these tables that have 20 years of data or 10 years of data or 16 months of data or something. And just to rewrite that could take some time. So absolutely, we want to be careful of that and be mindful of that. So I went ahead and threw it. It looks like I won't run the demo here just because of time, but I will definitely hang around if anyone would like to try to see it and do it. But, it wouldn't hurt you to do something like, do this at your own tempo. This is what I said earlier. Maybe create basically a view, build a new table that you're going to move data to, and build a view on top of that says, hey, I'm the old table name, but I see the new table, I see the old table. So as you start to move things over, maybe a partition or 2 or 10 partitions at a time, you can take your time. You can still run business as usual. You don't have to tell people, wait till I do this, and it's very beneficial. While I'm not going to run that demo, I'll just kind of show you. There it is right there, right? Build a new table, create my new table to put it in, use partitions, kind of rename the old table, build a view that sits in front of the old and the new, and then just do that looping based on partitions that we just talked about. Bring a partition over, drop it from the old, bring a partition over, drop it from the old. And in fact, my demo I had 5 partitions. I did this partition first, this building partition second, and then I just grabbed all 3 of them in the third pass. And it all works. In fact, I'm not going to run this, but I'm going to run it just by highlighting a whole bunch. I'm probably not going to talk to it, but I'll have it run in case we have time or want to talk about it. And the data will all be there. And at the end, what do you do? Of course, once you got everything over there, it's just a quick swing of dropping the view and then renaming the new table as the original table name. And then and you're in business, and then delete the old table kind of stuff. Again, this demo stuff is something you have access. It's on the very last slide as well. So next steps, absolutely, you want to be thinking about it, doing some valuation, etc. Make sure this is right for you, right time. And in that, we all want to do it ourselves, but we at Starburst, we want to help you too. So definitely click on these links. That first link will have a link to the bottom there. It just says, hey, specifically about Hive to migration, give me some help. I think we can have a SLA that will talk to you in a day or two, catch up with you, that kind of stuff. But don't hesitate to reach out to anyone at Starburst, any of our communication channels that are there, as well as myself, because we do want to help with this. We think this is important. We think it's the right thing to do, and we want to participate and help you out. Last thing I'll say before I stop and see if there are questions for me with the last few minutes left, would just reinforce again, feel free to click on that GitHub link, and you will find the same PDF you already have that you found this from, and again, mainly those two SQL statements. I even have a little Lester non-supported migration tool that I'm slowly working on. It's implemented as a Jupyter notebook as well. I anticipate I'll have time to build out 70, 80, 90% of the cases, and it will be a useful tool, but still a work in progress. With that said, I thank my my colleagues here, my all-stars, for helping out with the Q&A, and I'm going to just let the clock tick down. We have a few more minutes left. I'll be very quiet. If I don't hear anything, I'll start looking through the Q&As myself. But if anyone on the team that wants to come off mute and tell me about something I missed, don't hesitate to do it.
Hello, can you hear me?
I can. What you got?
A good question. How do you compare the delete mechanisms between Iceberg and Hive? So specifically deleting physical data to support privacy regulations. I kind of talked a little bit about the flexibility when I answered of like, Iceberg just gives you a lot more flexibility. You can delete within the partition. Sometimes Hive is tricky with that, but I thought your experience, you might have something to add on sort of the deletion mechanisms between the two.
I think I would introduce one caveat is that that sounds possibly not in favor of Iceberg, but I'll tell you the answer to that too. When we do a delete, so yes, deleting data out of Hive and deleting data out of Iceberg, the benefit here is Hive, especially without Hive Acid, you can only delete a whole partition. Unlikely that might fit your task, great. But if it is data intra partition, you may or may not have luck in Hive. You definitely can do that with Iceberg because it's, we think of it as the equivalent of row level or a row level kind of deletion, even if it was a statement that deleted billions of rows. The consequence I was going to throw, though, so that's the feature, we can do more fine-grained deletes. The consequence, though, is it didn't really go away yet because any kind of operation that changes state or structure is going to create a new version. So what you'd have to do in that case to truly delete it, you'd have to expire the snapshot up to the point where that last delete happened. So maybe once a week you do your purging because of your legal requirement. Maybe what you do is, because there's some benefit of keeping some of these versions, maybe you do that a little earlier than you're supposed to because it's still around, accessible via time travel or rollback. And then when your final hit comes, you do your purging of what they call versions. Hey, delete some old versions, and that'll take care of your physical deletion. Now, beyond that, when you go to the object store itself and how S3 or HDFS or GCP, whatever, Google Clouds, whatever, I can't speak 100% to that. But I have a feeling that if you have these privacy issues, you've already kind of thought through that and feel comfortable that your underlying storage vendor is going to also take care of it. But Iceberg, you'd have to kind of delete the versions that reference that same data that you deleted. That was the caveat. Any other big ones out there, Monica, or if that person's got some more follow-up to that?
There's another question about, how compatible are existing HQL queries running them against Iceberg? So how compatible are the queries?
Yeah, I think I don't have a good answer of one that isn't going to work for us, but generally speaking, we already have, by the fact that Trino, we're specifically talking about using Trino to do all this because, remember we said Iceberg is accessible from lots of other engines. So I'm thinking about Iceberg onward. As long as that Hive the HQL, that Hive query works today in our Hive catalog world, I'm not sure. I don't have any examples right now of something that's going to fail. Maybe this person has tried something, but I would say in general, because we already are an engine that already talks and was built initially dealing with HQL, HiveQL, that I don't anticipate much of it, or I don't want to say any because you never know. But I haven't run into anything that I could just quote out and say, hey, here's the 3 things that you just have to watch out for. Right.
Okay, and then you and I have an assignment for a awesome tutorial, so we'll follow up with that.
Yes. And for those that want to follow through and click on my migration tool, you'll see that it's pretty limited today. But the more you harass me there or raise some comments or do some work and do a pull request for me, the more we'll make that thing move forward, because it is right now it's a nighttime activity, not a daytime activity, but likely it will grow pretty quick here on my own, if nothing else. Cool. All right, I think we'll give one more alibi. It's 12 o'clock here Eastern time. Well, I appreciate everyone for participating, and I absolutely thank my fellow all-stars here for helping out in the Q&A. You guys have a great day, and we'll see you on a future event. Bye-bye now.